Welcome back, YouTube. This is David Lucas with Injection Molding Skills and More. Today's video is going to go over how plastics started and how they've changed the world. This video goes over basically when injection molding started, when plastic molding actually started in 1872. So I'm going to show you a little clip inside of this clip that shows you like a timeline of how injection molding actually started. If you've been watching my videos for a while, you know I started out in die casting. I did die casting from 1990 to 1996. I made parts for A.O. Smith, Shot Smith, Harley Davidson, stuff like that, using a plunger system with accumulators and stuff like that. So it's a little different. Plastics uses a screw, it augs it back, and then you shoot in using a check ring to hold it in place instead of a plunger. So I just wanted to go over this a little bit with you. I hope you guys enjoy this little clip inside of this clip. I hope it's informative to you guys. I'll be right back with the next part of this video.
What do toys, car seats, and bottle caps have in common? They're all made with a manufacturing process called injection molding. This process works by injecting polymers, like plastic, into a pre-made mold. Injection molding allows parts to be produced quickly, efficiently, and at low costs. It all started in 1872, when John and Isaiah Hyatt patented a device for heating and injecting celluloid into molds with a plunger. This method was then used to produce items such as hair combs, buttons, and collar stays. Then, in 1909, Leo Hendrik Bakelite discovered phenylformaldehyde plastic, otherwise known as Bakelite, a thermosetting resin that was well suited to injection molding. Bakelite was found to be better suited for this process than celluloid. Bakelite has useful insulating properties that made it ideal for electrical applications. The 1930s marked the beginning of the use of thermoplastic materials, which are still in use today. Polystyrene, PVC, polyvinyl chloride, polyolefins, and Perspex, polymethyl methacrylate. This laid the foundation of plastics use in manufacturing as we know it today. Soon, more items would be made of plastic than ever before. 11 years later, World War II created a huge demand for cheap, mass-produced materials, and injection molding was the perfect solution. Then, in 1946, American inventor James Watson Hendry built the first extrusion screw injection machine, which gave much better control over injection speed and quality. This method overcame a major shortcoming of plunger-style machines, the uneven heating of the plastic material. Now, items can be created more quickly, efficiently, and cheaply than ever before. In 1956, another American, W.H. Willard, received a patent for a reciprocating screw plasticator. This reciprocating screw mechanism sat inside the plasticator machine and heated mixed plastic and allowed material to be moved to the right places. This method increased mixing efficiency by reducing cycle time. In the 1970s, James Watson Hendry developed the first gas-assisted injection molding process, which allowed for the production of more complex designs, like those with hollow insides. It also allowed for greater precision while reducing surface blemishes, sink marks, and internal stresses. The improved design flexibility also meant better strength and finish, as well as reduced production time, cost, weight, and waste. In 1972, industrial robots and injection molding were combined for the first time. Using robots to perform secondary operations while the injection molding machine is working led to greater increased efficiency and output. At this time, mold design and process refinement were still expensive and required a lot of trial and error in the physical testing of new mold configurations and process settings. In 1978, mold flow simulation software was released. Engineers and designers were able to leverage the software to monitor injection pressure and temperature to optimize production, eliminating problems before they became expensive. 1985. Milacron introduces the first all-electric molding machine, which helped reduce energy costs and reduce the environmental concerns of hydraulically powered injection molding machines. By the end of the 1990s, Moldflow had released Moldflow Advisor, which opened up the technology for people who weren't dedicated plastic engineers. This software also made the process cheaper and easier to use, and opened it up to an entire non-expert audience. When Autodesk acquired Moldflow in 2008, the process was paired with CAD and CAD translators. The software's focus shifted to a strong emphasis on ease of use and the user experience. With this booming popularity and the increased global demand for products, we began to see the integration of injection molding into other, more customizable applications. By the late 2000s, improved automation capabilities helped significantly cut down on labor and costs. And as the world became more eco-conscious, the industry saw a shift to using recycled, renewable, and reclaimed plastics. In 2010, Moldflow created the first cloud computing offering, providing computational power for optimization and design of experiments. Today, injection molding is used by engineers and designers to create almost everything you see around you, from tables and chairs to food containers and mop heads. As we progress, injection molding will tie further into the cloud, making the technology more accessible and collaborative. With injection molding cementing its capabilities into new integrations, the opportunities to create are endless. The future of manufacturing is clearly being molded for a new era of innovation.
Is injection molding expensive? Orange Plastics Academy. Injection molding consists of many steps. Some of them constitute a one-time investment, such as design and mold creation. Others grow linearly with your desired output volume, such as raw materials, assembly, and shipping. This brings some complexity when trying to calculate your overall production costs beforehand. Fixed costs. Let's look at startup costs. The most important investment in this regard is the mold. Mold cost all comes down to the desired production volume and product complexity. If you wish to manufacture 2,000 units of a simple plastic toy, your production is going to go with a single cavity aluminum mold. Now let's turn to the other end of the spectrum. Say your product requires much higher volumes and is made from multiple components, such as a remote control. Then you'd probably want to make a 12-cavity hardened family mold consisting of 4 fronts, 4 backs, and 4 button trees every shot. In other words, there is no such thing as a single cost estimate for the mold investment. It all comes down to part volume and complexity. Your injection molding partner will help you select the mold most suitable for your project, which preferably results in the lowest average fixed cost per part. Contact info@orangeplastics.com for a free quote. Variable costs. In addition to the fixed mold investment, injection molding comes with variable cost factors for raw materials, assembly, and shipping. These costs tend to grow linearly with your production volume. Material costs greatly depend upon the type of plastic your product will utilize. There are many different kinds of plastic, each with different properties on flexibility, durability, and resistance to heat, cold, and chemicals. Plastics are often bought in kilogram units, with prices ranging from $1.50 to $8 per kilo. Polyethylene and polypropylene are 2 common types of plastic that have commodity prices. The final cost factors, assembly and shipping, are heavily dependent upon the specifics of your project. How many assembly steps does it take to get to the finished product? How is the product supposed to be distributed across the world? These questions are key in determining total variable cost. In a similar vein to the fixed costs, there is no ballpark estimate for variable costs. It's all very much dependent upon your specific project. The first step in your production journey should always be to get a good estimate of your costs. Ask an injection molding company for a quote.
Okay guys, I'm back. I hope you guys enjoyed that little clip inside of this video. I was trying to get as much information as I can about when plastics started and what it's done to the world today. You can see like we've made everything from car seats to Tupperware to clothes hangers to car parts. I mean, most cars are all plastic. So just wanted to go over a lot of that with you guys and let you see what I see in the industry. I've done automotive in my life. I've done housing products. Now I'm doing firearm stuff. So I work, like I said, I'm doing stuff for the military, you know, in the law enforcement. So, you know, so let me know. I know I'm rambling on. Let me know what you guys want to see in the next upcoming videos. I thought about doing one over water flow, what baffles are, what they call it, the Reynolds number, what that is and what it stands for and stuff like that. Just go over some stuff like that. So if you guys have any ideas, please comment down below. Let me know. I really do appreciate everybody's support to the channel. Please like, share, and subscribe. Peace till next time, okay?